Hello everyone. In this video, let us solve three problems from Sadiko exercise. So let us start with this question 1.4. A current of 7.4 ampere flows through a conductor. Calculate how much charge passes through any cross section of the conductor in 20 seconds. So what is the given data? Current is given, that is 7.4 amperes. Time is given, that is 20 seconds. Then they are asking you what is the charge which is passing through this. So we already know the formula for this, that is I is equal to dq divided by dt. So now if I want to find the charge, what I will do, I will take this charge on the left hand side, I will transfer this dt to that side, so I into dt. So now if I want to find the charge which is passing through a plane or any cross section in a particular time interval, okay, I will integrate this. So I will be getting the charge here, dq, total charge is q now in this particular interval. So here I will get I into t. So this is the formula. So q is equal to, what is I? It is 7.4. What is time? It is 20 seconds. So this will be 148 coulombs. So answer is 148 coulombs. So the time here is already in seconds. So I am directly substituting this. If it was 20 hours, then I have to write it as 20 into 3600 because I want to convert hours into seconds. So this is 148 coulomb is the answer. So now let us see the next question. Determine the total charge transferred over the time interval 0 to 10 seconds. So here the time interval is given 0 to 10 seconds and I of t is a function of t now. Okay, it is not a constant, it is a 1 by 2 t. So now I of t is equal to 1 by 2 t amperes. Time interval is given 0 to 10 seconds. Now we know I is equal to dq by dt and q is nothing but it is the integration of this time. So that is from the time interval t1 to t2. So here it is 0 to 10. I can substitute this interval here. Okay, because here I can consider dq, that is 0 to 10, the total charge will be q now, and here it is 0 to 10 I into dt. So what is I? It is 1 by 2 t into dt. So we know that integral of t is t square by 2. So 1 by 2 into t square divided by 2, and here I am substituting the limits 10 and 0. So t square by 4. And here it is again 10 and 0. So this one will be 10 square divided by 4, which is nothing but 100 divided by 4, which is nothing but 25 coulomb. 25 coulomb is the total charge transferred over this time interval 0 to 10 seconds when I of t is equal to 1 by 2 t amperes. Next, let us see this. The charge entering a certain element is shown in the figure. This is the figure now. It is the charge versus time. Find the current at t is equal to 1 milliseconds, t is equal to 6 milliseconds, t is equal to 10 milliseconds. We all know how to find. See, this is a ramp function. We know I is equal to dq by dt. Okay, we have to find the current. I is equal to dq by dt. That means it is the differentiation of this particular graph. Current is differentiation. If the charge graph was given, then it was integration. So now we know that this is a ramp here till 2. Differentiation of the ramp, you know it is a unit step. So now the value that is till 2, 0 to 2. You can see here this is 30. On the y-axis you have 30 and here you have 2. So what will be dq by dt? 30 divided by 2, it is 15. It is positive 15 because it is an increasing ramp. Okay, so now here it is 15. It is a magnitude of the step, and here we have a unit step. That means it is a constant. So differentiation of a constant will be 0. So from 2 to 8 it is 0. From 8 to 12 there is a decreasing ramp. So once again the 30 divided by 8 and 12 it is 4. 30 by 4 it is 7.5. Right, it is 7.5, but since it is a decreasing one, the slope is negative, so here I am taking it as minus 7.5. This is the graph for the current. So now find out the current at t is equal to 1 milliseconds. This is 1 milliseconds, right? This is the current, that is 15. So now I can write this as 15 milliampere at t is equal to 1 milliseconds. It's not milliseconds, it's not milliampere, it is ampere, because see here it is given as millicoulomb, here it is milliseconds. So obviously 10 to the power minus 3 and 10 to the minus 3 get cancelled, so it is 15 amperes. At t is equal to 6 milliseconds, somewhere here it is 0. So at t is equal to 6 milliseconds, 0 ampere. At t is equal to 10 milliseconds, this one, it is minus 7.5 amperes. At 1 milliseconds, it is 15 amperes. So this is how you are going to find out the current. You have to find the current graph and then find out the values of the current at particular instant of time. So this is all about the exercise 1.4, 1.5 and 1.6.